just do what you love and don't sort of pay too much attention to people who tell you that you should or you should not. I think for AGI, like we're probably pretty adept at being able to understand those systems. All the time with the Gemini models, we have something built in called code execution, which gives Gemini the ability to write, execute, and then recursively debug if it needs to Python code in a sandbox. So I really love that Silicon Valley is very driven by, what have you built? What are you excited about? What can you do?
Paige, thank you so much for joining us today on the Stars podcast.
Thank you.
Pleasure to have you.
Yeah, thank you for having me. I'm really excited with the questions that you have lined up. And then also, I think the premise of the podcast is really fascinating. This sort of merge together of science and technology and the arts.
Thank you so much. Yeah. So to start off, can you tell us more about, how your passion for math and computing systems originated? I know you talked about in one of your online podcasts, first playing with an Apple II computer in a small town and how that kind of kickstarted your journey into programming games or getting more involved.
Absolutely. I think so many folks around my age or a little bit older started programming on Apple IIs or Commodores. My first Apple II was rescued from being thrown away. My mom kind of helped me hook it up, and an electrician friend got it all wired together, and it came with a whole bunch of manuals. So living in a small town, I grew up in Texas, and it sounds like y'all also grew up in Texas, or spent quite a bit of time in Texas. But my hometown was 1,300 people, in the middle of nowhere. So 15 miles away from the nearest grocery store. So the Apple II was kind of my first and best technological toy. And we didn't really have the internet at the time. Dial-up was kind of the best thing that you could get. And so I just learned how to use it. I learned how to build games. It came with a lot of games out of the box. So things like Moon Patrol, Zork. But it was always more fun to create my own. And then I saved up pennies and dollars over birthdays and ended up purchasing a gateway for my next computer, which came with a lot of math and science software. Again, dial-up was very unsatisfactory. It's kind of like a trickle of information. But all of the software included things like number munchers, but also things like Math Blaster, and then my favorite one, which doesn't sound like a game, but I promise you it was. It was called Grade Builder 1 Algebra. And so I just ended up teaching myself algebra and really viewing math as kind of problem solving and fun, as opposed to, I think if I had learned it in school, it would have been something a little bit more dry.
Can you elaborate more on the dry aspect? Because Jogger and I have at least noticed that most of the fields that we've kind of come to be passionate about, or the way we define passion is not that something's easy, but that you're able to kind of absorb it quickly, and you want to, kind of quickly grasp on it more.
Yeah.
And then you can realize you can intellectually expand it horizontally, vertically in different domains.
Mm-hmm.
And I feel like that satisfaction of you getting something and then being able to kind of reinforce it is kind of what morphs into a passion.
Yeah. And this ability to try and experiment and test things out and immediately get a feedback response. That was one of the joyful things about the Grade Builder 1 Algebra software, was that as you solved these math puzzles, there were 3 different games you could play. There was something called Soak Your Sibling, which was aiming at siblings on a coordinate plane, and you had to build a linear equation to get to your sibling. And then there was another one called Death by Algebra, which was a similar sort of situation, kind of like a game show. But as you played each one of these games, learned the concepts, you would unlock a new part of the story. So it felt like, in addition to being a little bit more playful, being able to get feedback response, you also were kind of on this journey with all of the people you were learning with, all of the characters within the game. And I think it's also, the TI-89 calculators, if you ever played with those. Yeah. Yes. Yeah. Being able to try out equations and then see them visualized dynamically. That's also very, very powerful.
Yeah.
And I remember when I was in college, took all of the usual suspects. You had like Calc 1, Calc 2, linear algebra, multivariable calculus, Diffie, like all of these things. And then like towards the end of it, like, you're able to pull in something like MATLAB or Python with NumPy and all the other libraries. I actually kind of flipped that. So when I first started, I was using Python with NumPy and SciPy, which really helped unlock a lot of the sort of beautiful parts of mathematics. As opposed to, I think if you're doing everything by hand, you don't get to see a lot of the visualization and you don't understand the systems involved, because you're just so far removed from getting that immediate feedback. So the more that we can bring visualization, computers, this kind of playful experimentation approach to mathematical learning, I think the better off we'll all be.
Cool. So I know you also mentioned like, being able to model the world in equations is kind of like what also kind of rooted your passion in math.
Yeah.
And I feel like I'm kind of coming to like a similar story in physics. So in high school, like I hated physics, but then when I got to college, you started learning about, kinematics and mechanics, like more thoroughly and properly. And then as you like, derived equations, you could kind of see that equation as like really in a way, like containing a lot of the continuous world. Like if you kind of, make a limit for theta to go to infinity, you would expect something else to happen, which does happen in the real world. So it's kind of satisfying to see how like, it's kind of like a function for the world. So I was just curious, was your experience kind of similar? Or like, what was your experience with?
I really started to enjoy physics when, particularly the labs courses. So there was an excellent professor at my university where I went to undergrad, named Dr. Dodds. And he had this physics lab that he would set up, a different one each week in the basement, which was a little bit creepy, but like it was also very fun, like to be able to play with the systems, to be able to kind of see again dynamically, visually things with the oscilloscope, or being able to kind of track the motion of the systems. All of that feels very magical. And as you learn these concepts, suddenly you see everything in a new way. Like being able to understand why the horizon looks a little bit darker blue on some days, or why you might see sort of diffraction patterns whenever you're like wearing sunglasses, those sorts of things.
The first time in high school, Jonik and I were like playing around with a bit of like docking software with drug discovery. And the first time I opened, I think, AutoDock and like loaded a ligand and like a protein and pressed the play button and watched the ligand jump around. I took a video, put it in the family group chat. I'm like, wow, so cool. It was the first time I could actually sort of, because like in like class in biology, you might learn in high school, like you have the receptor and like the binding site and et cetera. But once you could actually see it like, fully like dynamically and sort of move around with it, zoom in, zoom out and see the different shapes and the regions, it just felt so rewarding in a sense. And like, I felt like digging even more, like as to, why did the drug like bind that way as opposed to any other way. It's really interesting.
Have you ever read the book called How Things Work, or the new How Things Work?
I have not, no.
I will send, I'm going to send you this book, but it's also, kind of wonderful because it walks through everyday things that you might encounter. So things like seatbelts, or ceiling fans, or like mechanical keyboards, or cell phones, touch screens, those things. And it goes into great detail about the physics, the chemistry, or the math that might be involved for making all of these things work.
Yeah.
And again, it's like, I think it gives you an appreciation for how much kind of creativity and understanding is required just to interact with the regular things like microphones that we interact with every day.
I think you're bringing up a really great point that John and I have kind of been like, we've been feeling, but we haven't been able like to find it throughout our high school. And we only came to kind of realize it more in college. Yeah. Is that gratitude is more so like a lens for innovation and also like growing intellectually. And so what I mean by that is like the other day, John was he called me and he's like, this is the table from our perspective, right? But what we're taking for granted is, all the atomic particles inside of it and all the motions, right? Like right now, like DNA is being synthesized in our body. So we're not really like thinking about that.
Yeah.
And so you could think about all these and kind of like take this to your leverage if you want to like further study the world and see how things work. But on top of that, on your point of microphones, right? back in the day, microphones didn't exist, and now we take them for granted. So maybe, yeah, like if you want to innovate in the field, and this is kind of something I also read from Paul Graham's essays, is that you have to kind of like think about something that would be taken for granted in the future.
Yep.
Something that would become like the new norm, maybe AI.
Exactly. Ambient AI.
Yeah.
So just like we're reliant on so many things like internet, Wi-Fi, ambient Wi-Fi almost now. Ambient AI should be, I think, probably pervasive in the future, at least, in the next couple of years, probably sooner.
You also spent some time at GitHub, and we'd also love to learn more about your experience there. So in one of your online podcasts, you mentioned doing user experience testing and helping craft behavioral patterns for GitHub Copilot amidst the pandemic. Could you walk us through what the process looked like and what you learned that users exactly want?
Yeah, so I spent a little bit over a year at GitHub during the pandemic. It was amazing, like very talented folks working there. When I first joined Microsoft around that time, Nat Friedman was still the CEO of GitHub, and he is a wonderful person, also doing a lot of like the most creative side projects I have ever seen. So like being able to read ancient scrolls that have been burned, like also measuring the sort of plastic particulate matter and various foodstuffs. But just a really, really driven and very passionate person. And he was really the one to push forward the testing for Copilot and to make sure that Copilot would sort of get launched and kind of this collaboration with OpenAI. I was fortunate enough to be testing. There was another product called IntelliCode at the time, which was kind of an old school approach to code completions. It was only 1 to 3 lines at a time. And it was mostly done through an IDE called Visual Studio, not VS Code, but Visual Studio, and then was getting introduced in VS Code. And I was asked to compare the experience for like this very nascent Copilot before it got released to IntelliCode, and to also kind of articulate to leadership what the change in developer patterns might be between this 1 to 3 lines completion versus the huge even at the time with GPT-3 the big functions that were getting released. And then I think the first iteration was using GPT 3.5, which was even so it was really magical to start understanding that instead of software development being this kind of like painstaking thing that felt, now it feels very reminiscent to the punch cards, right? Where you had to like painstakingly like punch out programs and then send it in and then wait for a while and then get a response back. Programming even just 5 years ago was kind of like that. Whereas now it's kind of supercharged. You go to something like fragments from the E2B team or v0.dev, you can just describe in natural language the app that you want and get a pretty reasonable result.
Right.
So the concept that you were mentioning before around testing things and then getting an immediate response, we now have that for software, and we didn't have that before.
No, definitely. I think we recently had a class where one of the founders of Cursor came by and started talking about their work with the product, and it was so fascinating to see how, like, I think in the past there wasn't sort of this like little AI mentor telling you, fix your code here or how to debug.
Yeah.
Which I think was, it still is a very critical skill when you're learning how to code, learning how to debug, learning how to, write test cases and actually check, like validate your own logic. But I think it's really interesting to see how far we've come in terms of like AI helping us sort of, there's still a debate of whether AI will replace us as opposed to help us accomplish more efficient tasks, which I think we'll also discuss.
And I do personally, I feel like AI isn't necessarily going to replace software developers. It will just help more people be able to create even more innovative software patterns.
Yeah.
And that's something that I'm personally very excited about, because scientists, they invest a lot of time in becoming experts in biology or chemistry or physics.
Right.
They shouldn't have to invest a PhD's worth of time to being well versed in computer science in order to be able to efficiently analyze data or visualize patterns.
Yeah. Actually, as a follow-up, I wanted to ask, so Amjad Masad, the guy who made Replit,
Yeah.
he was talking about how, like in a world where we're going towards like making an app, something that's quite easy with like a click, right?
Mm-hmm.
He said that you have a distribution of programmers in our current society, the good programmers who are like very proficient, and then people who don't have programming experience.
Mm-hmm.
And the ones in the middle are just like software engineers, like gluing APIs together.
Yeah.
And he mentioned that, in a world where we're automating all this stuff, Replit, other companies as well, the people at the top will become even more productive. People at the bottom will definitely get a head start, but the people in the middle will kind of become jobless. And so I was kind of curious to hear your take on that as well.
Yeah, I think that's, and I love what Amjad has done for Replit. It has also democratized software development in a lot of ways and has made it easier than ever to deploy software once it's built. Like Cursor, really great for kind of building first prototype, making it work on your machine. And then Replit, I feel like is very good at helping deploy it to actual infrastructure. I do think, though, that that's assuming that people won't kind of take the initiative to kind of evolve their patterns or to learn new things. And so in general, I don't think that those developers in the middle might stay stationary. They might have, passions that they're really personally invested in aside from their careers, and find new ways to help software accelerate those passions or, perhaps learn or upskill to become, better developers. But I do think that we're really, really kind of concerned about, AI's impact on the workforce. But humans are very resilient, or at least that's what I've observed. And so if we invest time in helping folks understand what AI can do, how it can help them, and then kind of educate them on new potential things that they can accomplish, I think the world will be a little bit more positive than folks are perhaps imagining. I do think, though, that the more people becoming developers is a huge net win for the world.
Definitely. Yeah. So on this note of like, I promise I'll switch back from Replit.
No, Replit's great.
Yeah. Like, so, apps like Replit are also kind of going towards, like nobody with programming experience can like make an app and even earn money off of it. Yeah. And, earlier you mentioned this idea of like, testing things and getting immediate feedback and kind of like iteratively like building on that. And I was curious that if apps are kind of like abstracting the whole coding process and we don't really know internally what's going on, so it's kind of quote unquote a black box from our view, do you think that's really beneficial for, generations moving forward? Like the only immediate feedback we'd be getting is at the level of maybe natural language. But again, nothing guarantees that natural language might be right or it could be hallucinated.
Yeah. And then there's also this perspective that ultimately there won't even be a need for a user to invoke via natural language the thing that they're after. The systems will just kind of automatically know, kind of like a concierge of like, oh, hey, like you're coming back from the gym, I'll have a towel ready, or something of that nature. I think a similar analogy could be, these days it's people might know how to program at the Python level, but they might not know anything about compilers. They might not even be able to kind of go down to a little bit more of a less script friendly language like C++. And then they certainly don't know how to debug things like kernel problems.
Yeah.
And so today, like even for really, really highly capable and very proficient software engineers, they might only be, well versed in Python, and maybe some kind of like system level architecture, but not really anything lower. I do think that for a certain category of folks that are just trying to build simple apps or to do data analysis, they don't need to be able to dig down really, really deep. But I do think that there are always going to be folks who kind of want to tunnel vision and who want to understand deeply all of the constituent things. Like today, we still study physics, we still study math. So hopefully in the future, people will still derive like personal meaning from being able to understand more complex systems at a very fundamental level, as opposed to just relying.
I think quickly going back to sort of the beginning where we talked about your passion for math and computer science growing up.
Yeah.
And we sort of, referred to, I think John and I have also come across a similar experience in high school with education being a bit, quote unquote dry or a bit,
Yes.
very like, here's a bunch of formulas, plug and chug them, derivative is, slope, etc.
Yeah.
Without actually going into the derivations or the complete details of why things are the way they were. And so, as a very quick follow up, do you think the current education system, it's a big question, is doing an effective job at getting students to think more deeply about why things are the way they are?
Oh, heck no. Like zero chance. Like I also, but very, very biased. I mentioned I grew up in a small town. I went to public schools my entire K through 12 schools history before going to Rice. And even while at Rice, like the sort of introductory physics, math, computer science, like biology, chemistry courses that I took, I would always kind of, listen to the lectures.
Yeah.
But then MIT OpenCourseWare had just started. And so I would just watch those videos because
real stuff happens.
And it was the professors, and I was very fortunate to have really great earth sciences professors and a really wonderful physics professor and collection of physics professors. But the MIT courses were always just so much more engaging, interesting, like demo heavy than some of the other courses that I might have taken. And so I feel like we're doing a very big disadvantage to students by not kind of having more personalized education, but also given that we live in kind of a global and definitely video documented world these days, like making sure that all of the best educators and the best professors are getting that content to students, which could help them learn. And then over time, like maybe the best teachers, the best educators are AI educators. There was something when I was in, I believe, 7th or 8th grade called accelerated math, which would give personalized like math problems to students as they finished them. And it feels like we definitely need to start investing in personalized education.
Yeah. So you brought up a really good point, on like, learning through MIT OpenCourseWare and then also taking college classes. And it's reminding me of this, distinction between self-learning versus, taking classes. And this might be a hot take, but I was wondering like, if you think it's worse to go to college nowadays versus, we're seeing a lot of more young people just kind of build apps on their own and like, build software on their own, learn programming, which is quite easy online. Whereas other things like learning hardware, like learning math theory might not be as easy.
Yep.
So I was just curious, like, what should people do nowadays? If, they just want to learn computer science or math, is it, the best investment to go to college?
As we record from Stanford campus. but I that's a great question. I do feel like one of the benefits of university for me was being around other people who are really passionate.
Yes.
So being able to bounce ideas off of people, especially growing up, like I mentioned, in the middle of nowhere. Stanford also has really wonderful professors that can help guide and focus research and work. Like it's a great place if you want to build a startup to recruit engineers to build a startup. So I do think it is worthwhile to consider going to university if you're still trying to figure out what you want to do. If you want to meet other like-minded folks and you do want to invest in networking because you haven't had the opportunity to do that already. That being said, things like Y Combinator can also unlock similar sorts of environments. All of the founders that get accepted to these accelerator programs are really passionate and driven as well. So I think it's more about finding those environments where you can learn and to be around a lot of other people who will push you to be the best version of yourself, as opposed to just saying like, all right, like 4 years of my life, like countdown, like let's just go and sit through classes, sort of thing.
Yeah.
Because university education, it's what you make of it.
Yeah.
And I do feel like we've gotten into this really bad pattern where folks consider it almost like a jail sentence of like, I'm investing 4 years of my life, I get a piece of paper, and then sure, I will get a job without really trying to learn or to grow throughout the entire experience.
Yeah, I think you bring a good point from in a prior conversation with Rahul Pandey, who made Taro.
Yep.
He was talking about how, at the end of the day, life is just a moment of like experiences. And I think the way I've kind of come to view college now is like, it's not necessarily about the classes. And like, as you mentioned, it's about the people. And I also felt like I've become like more of like a driven or motivated person based on like, the culture, energy on campus.
Yep.
And so I think at the end of the day, right, it's just really the recollection of experiences that you have from college, because that's really all that you have.
Yeah. I will say that when I was being forced to take courses, and it always felt like being forced to take courses, I got much less out of it than when I would learn kind of the same concepts or relearn the same concepts in order to do something for my job, or in order to complete a project. Like, as an example, I had a really small meeting, just me, wearable electronics company for a while that did a lot of work to create kind of like electronics-based jewelry. And then also I did a turn signal bike jacket. This was, over a decade ago. So we didn't have things like SparkFun. I had to kind of build my own kind of PCB and hardware in some instances, and kind of like hand sew the accelerometer and the LEDs in the back with like this kind of silver metallic thread. And suddenly physics was a lot more interesting, because all of the things that you had learned as problem sets or in textbooks, suddenly you had to like remember in order to understand how to make these things work in the real world. And like I always feel like if you're, exiting out of high school, going into Y Combinator immediately, you're probably going to learn many of the things that you would need to learn in order to be successful.
Yeah, I'm really glad you mentioned that story, because recently, like, my bike broke on campus.
Yeah.
And initially, as much as like frustration as it caused, like, I was really glad that it broke, because like I learned so much in just repairing it and like, using like different equipments and like grease to kind of like put things back together. And I was like, I take a lot for granted with the bike. And it almost felt like having a child to kind of take.
Awesome.
Yeah. Yeah. So moving on to, the big thing today, AI agents. So we're seeing them on the rise almost everywhere with like OpenAI as operator. And I see a lot of startups nowadays are focusing on automating like common workflows. So I was curious, at DeepMind, what thoughts do you have, or like how are you coming to think about, the shift from LLMs to AI agents, especially when it comes to things like Gemini?
I've been experimenting a lot with agents as well, just to automate specific tasks for myself. And with all of the kind of open source frameworks and libraries that have been created recently, so things like Agent Ops for observability, and then also Crew AI, Composio, LangChain, Llama Index. All of these things make it really, really easy to orchestrate machine learning systems, I would say, or are kind of these generative model systems. Within DeepMind, we have a project called Project Mariner, which is kind of similar. It gives you the ability to kind of have Gemini operate different tabs, different buttons within websites, and kind of accomplish tasks that you just define via natural language. So similar to kind of like browser-based computer use, those sorts of libraries or projects. I will say that I think it's going to get even more interesting with this concept of kind of ambient AI or on-device AI. At the moment, we have a version of Gemini, a smaller version called Gemini Nano, that's embedded within Pixel devices and also within the Chrome browser. And so if you can rely on a model that's, very small now, but, increasingly small models are getting better and better through things like distillation. If you have this model that's just kind of on board, embedded within your browser, that you can tell via natural language to accomplish various tasks, then suddenly the world gets a lot more exciting, because you don't need to have Wi-Fi in order to kind of have this model operate different things within the browser or within your computer, or within your phone. All of your data can be kept on device. all of your interaction patterns can be hyper personalized and kind of fine tuned on device for that model and for you personally. And you're not sending as much data to a server. And I think right now we're relying a lot on these models that are hosted on servers to kind of send information back and forth,
Right.
to try to make sense of a user's request. When the reality is that, fast forward a couple of years, I think we're going to see many, many more kind of smaller models, hyper personalized for users, local, and then maybe the more complicated or complex tasks get sent to the models to servers.
Do you think personalization would be, for AI agents at least, a good thing or bad thing, given that, like, yes, they're being trained on like, the user's data, like most likely, but it could kind of, like, the only thing that I'm thinking of is like, it could get to, an aspect where models are, too conservative in their thinking, right?
And very siloed.
Yeah.
So like the kind of bubble thinking that we're all experiencing via different social media platforms these days. It's a great question. One similar style approach, though it's a much more simplistic model. I worked on a project at Google about half a decade ago that was personalized screen brightness for Android and Pixel devices. And all it did was you have your cell phone, you pull up an app, there's kind of an ambient light around you. So it's able to pick up on the ambient brightness. And then it understands like, oh, well, in this ambient brightness, Paige opens up Gmail and then she like makes it less bright. So I will understand that for this kind of ambient brightness, when Paige opens up Gmail, I should make it less bright. And so I just did that for all of the apps that I had on my phone. All of the fine tuning happened on device, so nothing had to be sent to a server. But then periodically there would be kind of the weights or the kind of changes based on the apps would be sent back to kind of this world model. And it would learn from those weights. So it wouldn't say explicitly like, oh, Paige likes these configurations. It would just be like, all right, well, user, configured in this sort of way. And then that would update the global model. And so that would get better over time. You could imagine something similar happening for agents, and that it's like maybe it isn't so much like individual users' patterns are studied, but it's just kind of like overarching patterns or configurations are kind of incorporated to some sort of world model. And if there's a generalization that makes sense, then maybe that's percolated through the rest of the users.
Okay. This is kind of reminding me of like when John and I kind of learned about the internet in high school, and it was like the first thing to emphasize is like you have routes and they're all like scalable and like redundant. So if one route goes down, you still have like other routes to go through.
Yeah.
So I wanted to ask, like hypothetically, in a world where like we have all these AI agents, right? And a large chunk, just go like haywire, and we're kind of left with a couple of agents that are already personalized.
Mm-hmm.
Do you think it's possible, like, rewire those agents and like bring them back to kind of like a more, like a less granular agent if we need so?
Well, I'm probably being a little bit optimistic, but it's all, at the end of the day, it's all code, and it's all kind of models learning over time through various data. And if that's the case, then there's no reason that we can't kind of reinvent anything that goes awry, or kind of retrain anything if we need to.
Yeah.
But I do think that it feels like the world is definitely evolving to need to think of these kind of clever approaches for AI with the lens of distributed systems.
Mm-hmm.
And I think that's something that Google is uniquely good at. Like, it's very, very good at creating robust latency sensitive, like very well distributed systems and networks. Yeah.
I'm quite curious to learn more about, your experience at Microsoft doing data science research in the energy sector, and as well as its GIS technician.
Yeah.
How did these roles influence the way you perceive generative models and potentially, as we're talking right now about personalized education
Yeah.
with agents?
So I started doing machine learning around 2009 with but just like basic, like the simplest models you can imagine. So things like logistic regression, decision trees. I started doing GIS work as an undergrad because it paid very well for a student job, and also because I could automate it. Yeah, well, which I did not tell anyone that I was automating, but there was a kind of a software system called ArcGIS. I think it's still around, but there were departments around Rice University's campus, kind of like political science, social science, etc., that were dealing with massive amounts of data. And whenever the researchers would pull it into ArcGIS, it would just crash. And so, unless you were using ArcGIS on like the most beefy machine on campus, and that was only in like one part of the engineering design center. And so I realized this very quickly because I wasn't able to do the visualizations on my personal laptop. And there was a Python scripting sort of suite of libraries and tools that you could use within ArcGIS. So you were just operating directly on the data and not needing to pull up this like GUI. And you could create maps that way. And so that's what I did. And it gave me a healthy appreciation for data, a healthy appreciation for how data could throttle systems. Like you can't just expect all data sets to work on all computers. And then also kind of the reliability and unreliability of some data sources. So that I think is all really, really helpful as well for building models. It was helpful for data science, being able to understand variation in data sets, figuring out quickly how to understand irregularities in data. And at the time, there was also a really wonderful professor named Timothy Warburton. He was teaching in the computational applied math department, who was building visualizations of fluid dynamics using GPUs.
Okay.
And so this was, gosh, I want to say like 2009, 2010. So like
4 years old.
no, but it was way, way back before like deep learning even thought about using GPUs. Or before deep learning was even like, more or less a thing. And so it was really fortunate to be able to understand like, oh wow, these CAM guys are like programming in C++ and CUDA to be able to visualize these massive fluid dynamics data sets that they have using GPUs. I'm having to figure out how to work around hardware to visualize data sets for these folks in the political science or sociological buildings, and it just gives you an appreciation for how programs, data, and hardware all have to kind of align in order to build really interesting things.
And do you foresee any challenges with with data being the driving factor for training these models and making them more personalized? Do you foresee any challenges in terms of the ethical implications behind, personal user data and using that data to fine tune preferences for that given user, or perhaps the idea of gearing towards synthetic data generation? So like maybe in the healthcare sector, or education sector, or any other sector, like or energy, do you foresee any of these, any sort of hurdles in the future?
In the oil and gas industry, part of the reason why I went to the oil and gas industry after undergrad, one reason was because they said that they would pay for grad school. Another reason is because, just as an example, all of the world's best earth sciences data is not available today to universities, students, professors. These data sets are billions of dollars to kind of collect, to acquire, to sort of process after they're completed, the seismic data sets, and then also kind of 4D seismic, which is how do these big seismic cubes change over time. Like I said, billions of dollars worth of data, but it only exists between the Chevrons, the Shells, the ExxonMobils of the world. It's all locked down. And sea level rise and fall, so things that indicate climate change, the oil and gas industry knew about that, a decade or more before the rest of the academic world, because they had access to the data that would allow them to derive those insights. So that is an example, I would say, of data being unevenly distributed and being able to drive scientific breakthroughs that are kind of kept locked down to a couple of companies, like very, very large companies, but not able to be incorporated into these larger models. Like Google does not have access to those data.
Yeah.
OpenAI does not, Anthropic does not, etc. So given that, like the amount of just think kind of what you might be able to unlock with a generative model that is trained on all of the seismic data, in addition to the other data sets that are incorporated to the ones that we already have. The personalized user data, I think, is if you're just kind of fine tuning locally on device behind the scenes for a given user, I think that's okay in the sense that it stays with that given user. We have a really nice kind of data policy for our tools like AI Studio and the Gemini APIs, and that if you're paying for API usage or if you attach a billing account, then all of your data is kept private. So even if you're kind of using well within the free tier, like your data is kept private, provided you attach a billing account. And not incorporated into pre-training, not incorporated into fine-tuning. And we have been investing pretty significantly in synthetic data generation, as well as data generation from many different companies that are specialized in this. You've probably heard of some like Surge and Scale. So lots of different options for generating data as opposed to relying only on the data that's in the internet, because there's only so much of that, right?
Yeah.
Like there's and the data sets that I feel that could really be very, very impactful. Many of them are kept kind of locked down in specific industries, and so that's a challenge for folks. If anybody like wants to have dramatic increases in AI is applied to the earth sciences or climate change, they might consider like unlocking some seismic data sets for people to incorporate into pre-training.
Two quick follow-ups. So one is, especially in a sector where like you have access to like geological data, and like this data is important, right? When it comes to modeling things, and it could be potentially important for natural disasters. Climate change is not going away anytime soon.
Yep.
What do you think about this in terms of like the democracy level? Like, like everybody has kind of the right to know about, like safety measures and different things like that. And wouldn't like proprietary data here, and like, it's needed for competition and innovation, but how do you kind of foresee this, being an issue in the future, I guess, when it comes to, actual like climate change events occurring? And then my second question was more so like on the user side, when you mentioned like, you have these personalized data being stored on the user end locally. I was just curious if you anticipate any data storage issues when it comes to an age where like, we're kind of keeping track of almost every interaction with users.
Yeah. Certainly, I think we're going to have to get creative about data storage, or being choiceful about which data to choose to keep. Like maybe understanding that 80% of the data is pretty consistent, and so just having a couple of examples, you could dramatically kind of compress the amount of information needed in order to arrive at the same result for a given user. Like nobody needs to know that every time I wake up, I always open my work email and then I open my work calendar. Like if you understand that a couple of times, you probably got it. And then for the data that's proprietary data that's kept locked down within companies, I'm not a politician or a person who specializes in policy, but I do think that those companies have invested a significant amount of time and also money, and even like buying leases in order to be able to acquire those data sets. And so I'd imagine that they would want to keep them as kind of like a differentiated advantage, as opposed to releasing them out into the world. there might be some sort of like lifetime on data privacy, though, perhaps. And so I do know, as an example, like there was a Teapot Dome data set that's very outdated seismic that was initially meant for, I think, some sort of oil and gas or mineralogical exploration, and it got open sourced so many people can use it. And then there were also some kind of like well logs that were originally part of a railroad commission, and they've also gotten open sourced. So maybe over time we'll see more and more earth sciences data get open sourced.
Hopefully. Yeah. So moving more into like the philosophy of AI, we also wanted to ask you, like, a decade or so in the future, or even now, do you think that AI models are capable of like quote unquote dreaming? And what I mean by that is like also when it comes to like, AI models being able to store memories from what they're trained on. Because we think this has like a lot of implications maybe, in the future where like people want to kind of preserve their memories. Right. And we're not sure if, AI agents or AI models would kind of be that vector that stores memories.
It's a great question. I don't think I have that much of interest to say, though I do think that models are capable of taking very interesting side tangents. So talking almost in kind of like a dreamlike state, or being able to kind of give really interesting sort of thought process patterns. Like we just recently introduced a new feature in Gemini called Gemini Thinking Mode, which is I guess similar to O1 Preview, but you ask it in AI Studio, please do this thing, like, and it will kind of walk through, explain its logic and reasoning step by step. And if you can have this kind of internal dialogue of attempting to collect thoughts, identify patterns, and then build a plan to follow, I don't think that there would be any kind of or much of a difference between allowing it to daydream and sort of thinking of potential connections until it arrives on one. I don't know how one might save memories, though. I other than people who are sleeping connected up to sensors, like being able to track all of those data. I don't know if much of those data have gone into model pre-training, though. So that might be interesting.
That'd be quite cool. I've had like dreams where like I've thought of something, but then I wake up, I can like barely even scratch the surface of it. Yeah. And like it'd be cool to like wake up and then like go on your computer and just
see what
your dreams. Yeah.
I agree. I would pay for that.
Yeah.
So like YC company idea.
Yeah.
And it would be really straightforward as well to if you were to acquire kind of a proprietary data set like that of, you record yourself and your friends all having dreams and then trying to figure out what those dreams were about. That would be something that you could fine tune a model like DeepSeek on.
There's a blog, I think, posted by Dropbox where they're doing a study. I think during the shut-eye period, they would like use an AI model to essentially predict or like recapture the image or in the dream. So it really makes me wonder in terms of, what modalities are like AI can store memories in, whether it's sound, whether it's these images, whether it's, like more visual or like all the different modalities you can consider, whether it's, text and et cetera. And I think, to the point of memory and these AI models, like as I just asked about the capacity for these models to, encode memories, I was curious to learn more potentially about where you think perhaps the brain-computer interface and AI sort of intersection might be in the future. Right now we can go to like Vercel or Cursor, or like maybe type in like when using NLP, like make me an app or, make me a website. Do you think we're not far away from having potentially AI reader minds and essentially control, like automate tasks, like effectively and smoothly?
Yeah, I am a fan of models being able to anticipate needs. So based on what you're attempting to accomplish, being able to kind of realize like, oh wow, I've seen this pattern, 20,000 times before. So I might as well like kind of reframe the website to have the information that they're going to need, or to automatically, kind of fill out whatever is needed. That I think is very, very soon, probably within the next year or two. I don't think that I'm not a fan of invasive brain computer interfaces. That still gives me a little bit of the heebie-jeebies.
Your link.
But I think that non-invasive techniques have a lot of potential. I also really love what was the name of the Black Mirror episode? San Junipero, which was about being able to kind of feel like you're operating inside of a video game.
Okay.
And meeting other players. There were different kind of worlds and environments, and just being able to kind of have a digital avatar that feels like it's in a different context. I think that's also something really interesting, and probably very soon on its way. There was another sci-fi series called Upload. Have y'all ever
heard about it?
Yeah, and it's about.
Oh yeah, I think we were watching it on Amazon. Oh, yes, very, yeah.
Where you take so very fanciful. I liked the concept though of being able to kind of digitally upload yourself to an afterlife.
Yeah, exactly.
Which quickly became like a very capitalist afterlife. You had to pay for pretty much everything that you did and explored. So I also think that sci-fi is still like one of the best possible things that you could read to get a lens on how people are imagining the future.
Yeah.
And related to your kind of arts and STEM kind of concept, I think sci-fi can be a great inspiration for people who are wanting to build tech.
I think on that note, we read Ray Bradbury's like Fahrenheit in high school, and we're like, he's onto something.
Yeah.
With the robots in the kitchen and everything. Yeah. I think a long time ago, I think at least this debate has been going on for a while, that, when the human calculator first came out, everybody was thinking that it's going to, sort of prevent people from thinking for themselves or just exploiting it to their advantage. And there's also an opposing view of using the calculator to sort of work towards more complex problems, or, consider, I guess, more complex systems. So I was curious to learn as well, with that sort of effect with large language models or generative models, do you think that, being more reliant on these models for everyday tasks, coding, or even self-driving will, in a way, reduce our cognitive capacities, or enable us to, sort of take care of trivial tasks more efficiently and work towards more efficient or productive, I guess, objectives?
Yeah, I guess it's also a question of, what do you think is the important part of a scientific breakthrough? Is it being able to sort of understand this new thing about how the world works, or is it all of the kind of like painstaking handwritten math that took to get you there along the way? And it might be some combination of both. I do think though that there's a huge amount of potential in being able to kind of reduce the pain and the time that it takes to get to an insight or to get to an objective. Similar to what we were discussing at the very beginning, which is, if you have a significant amount of time between, trying something and getting a response, then you don't really make all of the connections that you would be able to make otherwise. I also think there are a lot of projects and a lot of, prototyping that just never gets built because people don't have all of the tools at their disposal and able to accomplish it. Like, I have always wanted to build a computer game. Like not a text adventure. Like, I can do text, but I mean like a real like 2D or 3D immersive video game. I've had so many story ideas, and I always get, maybe 75% of the way there. And then I'm not able to do like the last little bit. Like, I'm not really good at game design, or kind of like the avatar design. I'm not good at kind of making games beautiful. I'm not good at composing game tracks. So I can always do kind of like the back end stuff. I can create kind of a plot for the game, but I can't really do the last bit of polish. And now that's possible, right? So I can build kind of as a one-person indie game development studio. I can build simple games. I can share them with myself or my friends. And like all I can think about is, we've had 20 years of people probably in the same boat of, having these great ideas for projects or wanting to do some sort of analysis on the scientific data that they've captured or wanting to acquire new data sets and not being able to. And now they should be able to do that. It's just showing them how to do it with AI.
I was scrolling on our Twitter, I think yesterday, for like 2-3 minutes in between class, not 2-3 minutes. And I noticed that there was an 8-year-old who built an app using Replit.
Yeah.
And I was like in complete shock. And I was like, because usually, you feel like to break into coding, you have to learn what is a variable, what is a for loop, what is a class, what is an object, etc. Like all these sort of like iterative or sequential modules before you can do the big thing or you can have fun. And I think that really showed me, or like demystified the fact that you don't have to, be quote unquote ready to actually, mess with these ideas or play around and have fun. I think in a way, forgetting the idea of I have to do X, Y, and Z to be able to build something and just simply jumping directly into it and like, let me try and build something is, I think, perhaps a better way of learning.
Yeah.
And I was very excited to see how accessible, we're going back to Replit again. Replit was making app development, especially for an 8-year-old.
Yeah. Like think of how many people would drive if you told them that they had to understand combustion engines and carburetors and all of the mechanics of how the axles connect before they were able to like operate a steering wheel. Yeah. Like nobody would be able to get past that. And the learning all of it might give you a little bit of an appreciation, but it would also turn people away just because it's so frustrating. So
I also want to bring up a point also on Twitter. Andre Karpati recently coined this term called vibe coding.
Oh yeah. I love it. It's like a flow state. Yeah.
So I was curious to kind of hear your thoughts on that. Like even I've kind of experienced, using Claude and coding at the same time and things are kind of moving fast, it's smooth and it is kind of like a stream of consciousness and but I was wondering will this kind of lead to this coding brain rot in the sense where you're not really interacting intellectually deep with the code, but you're just kind of letting things happen. But yeah, you're just kind of immune to what's going on.
That happens with, for me, I really love this product. It's called fragments.e2b.dev. Like I mentioned, it's kind of like an open source version of v0.dev, but it's great at JavaScript, but also Python and other sorts of things. And so it feels really nice to be able to just say hey, I want to create, a marketplace to sell my Pokemon cards. Oh, that's beautiful. Put more emojis in it. Oh, that's wonderful. Now make it pink. And those sorts of things. And it's really interesting to see the code change in order to accomplish the task. It's the same for things like cursor and continue.dev to be able to see the way that things get edited. And I actually learn a lot more that way than I would by saying oh crap, I have to go look up the documentation. I am not a JavaScript human, so I'm going to have to learn if I need to pull in a library or if I can do this natively, should this go in CSS or is it an HTML thing? Mm-hmm. All of this would have taken, minutes, maybe even an hour. And more often than not, I probably would have gotten bored before I fixed it. So I feel the vibe coding state, if you are paying attention to the changes, you learn a lot more than you would if you were having to implement those changes yourself as you're building your application.
Yeah, definitely. I think this goes back to the point as well where we were talking about, I feel accelerating coding kind of makes it more enjoyable and fun, right? Because you don't have to spend an hour trying to fix a broken package or a dependency. Yeah. So I think hopefully that can also engage more people into computer science.
Yeah.
And kind of make it a more motivating factor.
Yeah. And it helps you see the beauty in it as well. It's mathematics. I will stand by this. As soon as I started seeing the visualization of math equations, That's what got me. Like it was, like being able to see things kind of visualized as a plane or kind of as a three-dimensional object, and seeing that expressed as math. Like that's the deal. And so it's a lot more fun to have programs visualized or kind of interactive than to kind of go through this painstaking process of out yourselves piece by piece.
Do you have like a favorite mathematical equation or like 3D um, sort of visualization?
Well, the what's it called? The zeta function is very pretty. Like but I do really, really love kind of Maxwell's equations. And the other piece that I think is quite nice is the you probably experienced this already as well, is my K through 12 education, not very good. But when I got into college and was taking kind of chemistry, physics, earth sciences courses, biology courses, all at the same time, and being able to see kind of the same equation expressed maybe with different variables,
Yeah.
but being able to describe the systems in so many different parts,
Yeah.
and to find out that calculus is real in all of these senses. That was also just like mind-blowing. So I feel like if you're going to be studying anything in university these days, mathematics and physics will not prove you wrong.
Yeah. So onto your point about something I've also come to realize, like, going from chemistry class to like physics, next period in high school, you would learn the same equation, but then it kind of like struck me how, not to get too philosophical, but there's no really such thing as like, quote unquote math or physics. Like they're all just describing this continuous real world, right? Life. And calculus is like sitting at the bottom, kind of just giving energy to everything.
Yeah.
How can we like make people realize that more?
It's helping people understand the beauty and it requires great communicators.
Yeah.
People who are able to kind of reach out and communicate in a way that resonates with other folks. Like I love Carl Sagan for that reason. Like I think he was very good at bringing poetry to the physical sciences and to the mathematical sciences. I think these days it's harder than ever to engage people in a way that's meaningful, and short enough, like concise enough that people will actually pay attention. And I feel like also, I love reading. Many of my cousins are less fans of reading. And so if people are spending more of their time, watching videos or listening to podcasts or whatever it is, then that's where they need to be taught. And that's where these concepts need to go in order to reach. So and it's not an easy answer. I think y'all are doing this. So cool. Congratulations. But it's definitely something that we need to get better at in a global sense, is how do we educate folks and how do we help them see the magic in these things.
On that note, like your journey from going like from small town to like leading product development at DeepMind is like really inspiring. And I wanted to ask you, like, how can we, in addition to communication, like, would you have any other ideas on how we can democratize AI education to, Gen Z, Gen Alpha, especially like when, majority of us are kind of like scrolling on TikTok or Twitter nowadays?
Well, if people are on TikTok, like make TikTok videos that explain fundamental concepts in physics and chemistry. And you can make it interesting. I definitely am going to send you that book. But the how things work. If you can make something as mundane as a seatbelt, or as like the lock in a door, feel like it's holding some nugget of the human collective intellectual progress, then I think people will actually pay attention. But there's been so much kind of unfortunate lack of investment in education collectively across the United States, that I think teachers there's some really wonderful teachers who are chronically underappreciated, but then also some that just view it as kind of like something that they clock in and they clock out. And, we will go over these 15 pages, and at the end, you will understand these 15 pages as opposed to unlocking the secrets of the universe.
Yeah. I think I recall in high school for me, I feel like for our math classes, like from algebra 1, algebra 2, geometry, that was all very, here's the equation, here's the variables, when do we use this, when do we not use them? And then when I got to multivariable calculus and in our TI calculator, we were graphing these paraboloids and hyperparaboloids and ellipses and et cetera, and learning so much more about the sort of like, derivations of physics equations and everything. And that was when it sort of clicked for me that I love math. That, there's so much more. It's not just sort of, you have to memorize this relationship, that you can actually develop a strong intuition for why these variables are the way they are, or, how you can maybe model like real world objects like this pot over here with a plant. Using these equations.
And what happens when you put something like when you multiply by a given variable, or if you're dividing a term by a certain number, how does that change the visualization that you see? That was one of my favorite parts of there was a course called quantitative hydrogeology, which was basically just like all of the physics that you learn in kind of multivariate calculus, but just talking about how water and gas kind of moves through Earth's systems. So like pores and rocks, or kind of aquifers, those sorts of things. But the professor wrote equations on the board, and then would circle terms and be like, all right, well, this is the term that describes the porosity of the system, or this is the term that tells you how fast the fluid is going to flow. And this is the term that does this. So if we multiply this by a given number, it'll be faster. Or if we divide it, it will be larger, or multiply it, it'll be smaller. And those sorts of things. And when you do that, when you describe math in a way that people, I think, understand from applications perspective, then suddenly it feels a lot more real.
Yeah, I think what's so beautiful about equations, at least from like my experiences also on this similar note, was like you can kind of make a mental model, play around with some variables, see what happens. And I realized I was kind of subconsciously doing this with genetics when, I was just learning about different like gene editing techniques. And you could look at technologies like CRISPR, which would, you have the bacterial immune system. You're kind of like, you're switching one thing, right? You're making things negative, and you're using that immune system to kind of like defend from, or like you're using the immune system to kind of like engineer ways to like defend from, pathogens. And I feel like being able to kind of realize that everything's like an equation, or like can be like mathematically approximated like from the ground up, and then like, treading things around is also kind of like a way for us to do like RL in our heads. Right. Because we get to see, or play around with the world, even though the world's kind of still like stationary.
It's like that scene in The Matrix with the zeros. It really does. When you understand how the systems work, like you suddenly start seeing a lot of possibilities that you wouldn't have unlocked otherwise.
It's pretty interesting you mentioned. I think for me, when I'm coding a piece and you open a new file, it almost feels like you're creating the entire new DNA of like maybe a virtual like file or something. Like if you forget a semicolon, if you're in C++, you get an error. If you don't define a variable, then you might get some sort of error. Or if you like an infinite loop, or all these different sort of edge cases, it feels so delicate, and that every letter you write contributes to the identity or function of that piece of code. So I think there's so many beautiful parallels to be appreciated between life, code, and math. Do you think AGI will become so complicated to the point that we can't explain it to people?
So I think the AGI, big loaded term, right? And I think everybody that you would talk to has their own definition of what AGI is and what it isn't. from my perspective, it's a model that can be generally useful. So able to accomplish a broad spectrum of tasks, at least as well as a human might be able to do it. In which case, like, we're pretty much there.
Yeah.
Like that's, if that's the definition of AGI, like we are pretty much at the place where models are as good as humans at doing pretty much every task. In which case, like, we can still explain how these systems work. We can still build interpretability tools. And from that perspective, I think right now we're in a pretty tractable place. Where it starts getting interesting is kind of the ASI perspective. So being able to accomplish tasks or to do things that humans don't understand or can't explain or have not been able to do yet. And then whether or not we can sort of distill back that information into our own understanding, I think is a good question. The I can't predict the future, but I do believe that humans are, like I mentioned, they're pretty resilient. And so I think for AGI, like we're probably pretty adept at being able to understand those systems. For ASI, it's anybody's guess.
We're moving quite fast because like whenever I call my parents back home, then, like they would kind of tell me about like, when they were kind of young, like in high school,
Yeah.
barely any access to computers.
Yeah.
The internet was just coming out at the time, or not the internet, YouTube.
Yeah.
And, like there's so much that we're able to do nowadays that's really accelerating learning. Like if I'm like, studying computer science, I can ask Claude a question. But if I think for a second, we're in a world where like I had all these burning questions in a Google document that I had to wait to ask to somebody, it's like, gosh, we're like way ahead.
And they didn't even know the answer. Like
Yeah.
the another kind of thing that feels wild is that when I first got to college, there was no kind of like ubiquitous Wi-Fi data. There weren't people really weren't using cell phones that much. And so you would have to print out maps, like MapQuest maps, and try to navigate your way through cities. No such thing as Uber. So like you had to either figure out how to use bus systems or navigate on foot. And it kind of limited all of the kind of paths and the adventures that you could have because there were so many hindrances to being able to explore. Like you couldn't pull up a map and figure out how to get yourself out of a problem. You couldn't, if you were trying to take buses and the buses stopped running, you wouldn't have any insight into when the next one was coming. So people just kind of ended up staying in their own part of the world. Whereas now I think that since technology has enabled so much more mobility, you can learn a lot more. You can see many more things, interact with more kinds of people, and it's all of that feels net positive.
Yeah.
And I remember also when MIT OpenCourseWare first came out, they had they weren't using YouTube at first. They had like tiny videos that were embedded within the websites, and it was still like just mind-boggling that we were getting this video content out. It will be even better in the next 5 years. So
I'm thinking more in terms of, with I sort of note down that AGI will continue to like rise and grow, or like at least we're almost there.
Yeah.
Or in fact already here. I think what I'm sort of concerned with or curious about is sort of how humans will react to trust these systems.
Yeah.
I think we've seen with like Waymo or Tesla, we have like you have autonomous, driving, but you also have the screen in front so that you can actually physically see or trust the system that there's a person walking by or maybe a cyclist or a tree, so that the computer can interpret these surroundings.
Yeah.
I wanted to sort of ask if you see any parallels with AGI in that how we can sort of, or any parallels in AGI that will enable us to trust these systems a bit more, especially given hallucinations and, sometimes decisions that we aren't able to exactly trace back to where they came from.
Two tools that I use all the time with the Gemini models. We have something built in called code execution, which gives Gemini the ability to write, execute, and then recursively debug if it needs to Python code in a sandboxed environment. So it's kind of like you give the model a calculator, like a fancy calculator, but it can do the things that it needs and test its work before giving you a response back. And then we've also have a tool kind of baked in called grounding with Google search, which provides citations. So if the model gives an output, it will kind of cite in line of like, the reason why I'm making this claim is because of this, and then give you the ability to kind of go search and to see if that's valid information. Those things feel very helpful in the sense that it gives me a little bit more confidence in text outputs. I think we have a long way to go in terms of generative video and generative image confidence checking. So I would love to have, as an example, if I generate an image, something that's able to overlay, like, look, this looks like a some sort of a gap, or this person's fingers are perhaps like a little bit splayed too much, or those sorts of things. I haven't seen anything like that just yet, but I would imagine that the folks at Midjourney and at some of the other generative image and video projects like Imagine and Video are working really hard for these things. I also dislike that those require me knowing to turn on code execution and turning on search grounding. And I don't think most folks out in the world know to do that just yet. So there's a big education component. I think also baking in guardrails. So the Gemini app incorporates search automatically. I think OpenAI, the ChatGPT model, does this as well. But I'm not sure if Claude does citations. Just
That's perplexing. Yeah, the value.
Yeah.
I think one thing that kind of concerns me when it comes to like AGI, at least in the, like, moving forward, is just like what to write and what's wrong in terms of data. Right? I know like we have
what's right and what's wrong, like in
as
general. Like,
I think that too. And I guess like mainly in the note of like, if you're given an image, how do you distinguish it from being real or fake? And I know like watermarks are being developed, but I'm curious to see how this pans out in like areas like healthcare, or, where healthcare data kind of being labeled as you don't know whether or not it's real, could inform, the level of care that you give at a hospital. And that also kind of has a global implication in terms of like, which countries do better in terms of healthcare. And I think data is like the main value there. There's also quite a bit about sort of how you can psychologically, choose to respond to certain prompts. And it makes me wonder, how much empathy these models might hold in terms of, I might choose to present a given response in I recall there are different psychological phenomena you can use to, order words or perhaps rephrase questions to sort of manipulate the understanding of the user if they're not, super aware. So I'm also kind of curious, on top of your idea, as to how these models will behave in terms of being sort of psychologically unbiased. Does that make sense?
Yeah, and we're already seeing, like, I'm sure y'all have noticed as well, when you use the different models, they all seem to have very different personalities.
Yeah.
I really love Claude. I really like using the latest Gemini model, the Gemini 2 version. And then there are some others that's kind of like the Wild West. I will not name them, but it's there's certainly, a differing level of empathy based on which model you select. And some kind of nudge you to ask more questions, which I think is a great way of learning and understanding and kind of testing whether or not something is true or something is valid. If a model is giving you, just like if a person is giving you a very confident answer, there should always be some ability to kind of interrogate and to reinforce that they're actually giving the correct answer. Data, like the quality of data, the integrity of data has always been a struggle. Like as an example, back when I was building models for oil and gas data, I would often look at well logs. And so well logs, as you're drilling a well, you have on the order of like 300 or 500 or even more variables that are being captured by sensors. There's kind of like a Christmas tree looking thing that goes down as the behind the drill. And these sensors are capturing, all of these variables every 3 seconds. Sometimes it's even more fine grained. And I would be capturing these very large kind of text TSV formatted or WITSML formatted data sets. Sometimes they would look great. Other times, you would get irregularities. And so I always had to go on site to kind of understand like, oh, well, the Christmas tree was actually, connected 10 feet further back. So like, I'm not capturing data at the exact place that I thought I was. And so, you have to kind of change your data or sort of correct it in order to get more accurate results because it was pre-processed or post-processed in a way that doesn't align with reality. And so we're building, these models based on pre-training data sets that may or may not align with reality. Post-training data sets that may or may not align with reality. And I don't think that there's going to be an easy way to kind of correct that other than just adding in more and more data from more perspectives.
Do you think there's a part of, how AI is kind of like fundamentally more like modeling the human brain, right, from neural networks? Moving forward, do you think there's a part of the human brain or consciousness that AI will not be able to capture?
Like there's, how humans, we only see visible light or we only see colors in a certain slice of the spectrum. And there's a whole like universe of things that are happening outside of the realm of the sensory data that we're able to understand. Like we can hear things, but only on certain levels. We can see things only on certain levels. Like I am positive that like there are all sorts of things that are happening outside of the realm of human understanding right now that we're not able to see or even to begin to ask questions about because we just aren't able to pick up on those frequencies unless we have certain kinds of tools that can help us derive those signals. So I wonder, like all of the data that we're using to train these models is kind of limited to the kind of frequency patterns that we have the ability to pick up on. So like visual things, videos, text, audio code, sounds, some kind of sensor data. But it's certainly not like the wealth of data and information that exists within the total spectrum of the universe. And so when we train these models, like they're only able to pick up on the frequencies that we train them up on. And that means that if there's something within a human that we don't really understand or know or have the ability to kind of capture data on, then we can't expect the model would be able to do that.
This is a really interesting point because I guess this reminds me of one of our prior guests, Lee Cronin, he's a professor doing like digital chemistry in the UK, and he mentioned that aliens do exist. Just not able to, pick up on frequencies to realize that they're, around us. So I'm curious, like AI, when they discover aliens, if that is the case. And then my second point is just that, like, if it comes to a stage where, we're able to deploy AI that is able to, be responsive to frequencies that we're not responsive to, wouldn't it just be a matter of trust then? It's kind of like somebody coming up to you and telling you a whole new world, right? And you just choose whether or not you think it's true.
I would want to, if the AI was able to pick up on those frequencies, I think we would have to give it the ability to use some kind of tool in order to do that. In which case we would kind of have to understand the frequency. I'm not sure, like he sounds very confident about aliens existing. I will say that I would want to have some sort of understanding as to what data the system was using to base that assumption and to validate it. And that's not just if you see a scientist come in with a claim, you ask first, like, all right, well, where is your data? What methods did you have? And tell me why you have empirical evidence that this is true. We should be able to ask AI systems the same question.
It makes me wonder, with, I guess, with Newton making these very fundamental discoveries in physics, it makes me wonder if, AGI will be able to sort of accelerate that in minutes, as opposed to waiting for a long period of time.
You can already do that. Well, not fundamental breakthroughs in physics, perhaps, but you can already say, like, hey, here are 5 different papers that were just added to archive. Create a new paper and methodology for that experiment that I can go execute on. And it's already able to do that for at least Gemini 2, probably like the OpenAI series and Claude series as well. And so if you can have models that are capable of reading 5 different papers, kind of understanding the methodologies for each, coming up with a new experiment that could help you learn more based on the future methods portions of papers, then like there's no reason to think that it wouldn't be able to have fundamental physics breakthroughs either. And when you think of something like AlphaFold, like I forget how many, hundreds of thousands of years of PhD time was mentioned that saved, right? And that was using, like, the first version of AlphaFold was using a very dated large language model kind of developed in a system. So it's gotten even better.
It almost feels like we would have like an AI Nobel Prize ceremony in the future.
Yeah.
Like Claude, Perplexity, Gemini attending. Yeah, so we also had some questions on, like personal growth as well.
Yeah.
You mentioned growing up in a small town. I guess first, what was it like growing in a small town? Like, if you were to go back now and live in a small town, would you, or would you not, and why?
So I think small towns now perhaps might have been different than small towns back then. As I mentioned, like, dial-up was like very few people, if any, had dial-up. And dial-up was as good as it got. And there were no cell phones, no Wi-Fi. So it felt very isolated. It was also a farming community, so pretty much everybody was farming family. Like, my family is 5th generation farmers. And my mom was a math teacher. So math in 2nd grade. I feel very fortunate in the sense that we mentioned, or we're talking about Nat Freeman a little bit before, and all of the plastics and particulate matter found in food. I was eating food that was all pretty much grown locally for the most part. And I don't think that that would have had as much contamination. You kind of knew everybody. So it felt very much like a community of people helping each other and looking out for each other. There wasn't a lot of curiosity. Like, the furthest most people went was going to a local community college or joining the military. But it was very quiet, felt very slow. And then kind of books and computers were literally the only windows that you had to something that might be more meaningful. So that was, it felt almost like living in a small box, and then like going to university was just an explosion, because suddenly, you find out about all of these things that you wouldn't have known otherwise. Like what was who was it? Was it Plato and the Cave? Yeah. Like living in a cave and like seeing things happen on the wall and not quite knowing what they were, and then finally getting to go out into the world. So that was what it felt like living in a small town. Now I hope that is not the case. I hope that, like, everybody living in a small town is able to like have full access to Wi-Fi and the internet, and to be able to understand that there's a big bright world out there. But at the time, it felt very, very kind of close and isolated.
You mentioned the cave analogy. I was wondering if there were any sort of expectations that were vastly different to the reality of attending college.
Yeah.
Like perhaps where there's sort of like whether, because we also have another question as to, perhaps the how we can move forward towards bridging the gender gap in STEM education. And so perhaps if you could elaborate a bit more on sort of what you expected, like before going to college, maybe growing up in a small town, and how that's sort of how your belief of, pursuing this pursuit of curiosity led you to hold different beliefs.
So I, growing up, the I competed. You grew up in Texas, so you probably heard about UIL competition. Yeah. Oh,
The UIL.
okay. Yes, like we're aligned. So like I would get entered because my graduating class I had like 42 people. I would just get entered into all of these academic competitions. And basically it's like, oh, you have a window from 9 to 10, like go take the social studies test. You have a window from 10 to 11, number sets, like those sorts of things. And so it was just kind of, oh, like Paige likes math and physics. Paige is weird. It wasn't like, oh, it's like a girl liking math and physics. That's weird. It's just like nobody likes math and physics. That's weird that she does, sort of thing. I think that meant that I just kind of didn't develop this understanding that girls were bad at math, because it like that was never really anything that was spoken at school or insinuated. It was just like if anything, it felt like girls were much better at academics than the boys in my class were. So my thought process was just like, oh my gosh, I'm going to go to college and everybody is also going to just be so in love with all of these things. And like, it will just be like talking until 2 a.m. every day about all of these things that I enjoy. And I got there and that was not quite the case. So do not feel like that is not the case for y'all. Like, do not feel like it is like that's rare. I think many colleges have bright and passionate and really really industrious and kind of people who are captivated with these concepts, but also a lot of people that are still trying to figure out what their joy is. And that was a takeaway for me, is that university doesn't just magically unlock all of the problems. I will say another thing that I was expecting was I walked into university and I was convinced, like I wrote my admissions essay on computational neuroscience. I was like, that's what I'm going to do. I'm going to be an MD PhD. Well, hey, clearly this is my future. And so now like point me in that direction, please. I would also like to work in this specific lab. And I got there, I found out that computational neuroscience was a grad student only program. Yeah. And the lab that I had wanted to join, I think it was an associate professor, an assistant professor. He had just gotten a tenure track position at NYU, so he was no longer there. And so it was just kind of redoing from day zero. All right, well, I can't do computational neuroscience, so I'll figure out what this cognitive sciences thing is. I have to have math and physics courses, so I'll do this earth science stuff. And that just, the exploration kind of was what the magical part of the university was.
So on that note, you also, online mentioned that, in the time you're growing up, boys were kind of expected to, do sports, and girls were expected to be leaders.
Definitely, yes.
So I'm not sure, at least from my experience, I don't think that exists too much today. But
really, have you like and y'all were in Texas?
Yeah.
Okay.
At least in our school.
Yeah.
But I was just curious, like I'm sure like still many people do feel like held back by gender norms.
Yeah.
So I was just curious what advice you would kind of have for them. If they are doing something that, should not be considered abnormal, of course. What advice would you have?
Yeah. In general, like just do what you love, and don't sort of pay too much attention to people who tell you that you should or you should not. I think the real magic happens when people find out what their passion is and then they just move full force towards it. Like I never expected there to be any connection between kind of geophysics or like geophysics and machine learning or math. And in all honesty, like when I was learning about GPUs and about kind of the fluid dynamics modeling on GPUs, I never expected that that would be useful in other senses. I had professors in the earth sciences that told me learning how to program was a waste of time and it wasn't real science. But if you find what you love, like suddenly at some point it all works out. And you shouldn't feel like your gender or what language you speak or where you grow up or any of these things have any sort of limitations on what you can do.
Yeah, definitely. We also strongly resonate with your support for not believing in credentials or acronyms as indicators of success.
Yeah.
And so we also wanted to learn more about how you think in today's job market or in society as a whole, how can we truly go about measuring people's potential? As opposed to in the coding industry, we have leak code. People just practice a bunch of problems and sometimes regurgitate these patterns.
Yep.
Uh,
Like it's like SFT, it's like supervised fine tuning. People are memorizing all the answers.
So I guess like I wanted to hear your perspective on what might be the best way to assess true potential.
I'm not a fan of leak code, by the way.
Me too.
Yeah, excellent. Well, I have to say the best measure of a person's potential is just asking them what they're excited about and then also seeing what they built. Because if you're building things and you're kind of taking the time to create something and to share it with the world, then that tells you a lot about the person who's building the thing. And about their ability to communicate what they've just created with other folks who might be interested. So I really love that Silicon Valley is very driven by, what have you built? What are you excited about? What can you do? It's very action oriented and contributions oriented, as opposed to the academic world still seems to be very invested in credentials.
Yeah.
And I've met many people with PhDs who are wonderful, and many who would not be able to build something new or to sort of think of a new concept or to think of how to experiment or test a new hypothesis. And if that is the case, then I think that's kind of detracting from this concept of getting a PhD in the first place. Like in the before times, you had to be able to come up with a novel series of thoughts, kind of test them out really rigorously, and then meaningfully contribute back to the scientific community, something like very important in order to be bestowed a PhD. So it had very, very like strong meaning and a lot of kind of shock and awe potential that you are able to get this very coveted thing. And now I think it's more like a conveyor belt. It's like people go to the school so they can pass the test to get to the university, so they can get the GPA to get to the grad school, so they can do the thing to get the PhD, so they can get the job.
Papers and the citations and the index.
Yeah, which sounds exhausting just even thinking about it. And that's not, it doesn't necessarily deliver anything useful or meaningful to the world. And I think right now everybody is trying to figure out this introspection of what can I do that would deliver the most meaning and the most value to the world at large, because so many things are broken.
Yeah.
And as humans, it is our collective responsibility to fix it. So if we're devoting 24 hours of our day every day to something, like it sure as heck better be a meaningful something, as opposed to just like focusing on getting the GPA or a piece of paper.
Kind of reminds me of stoicism, because I know like, I don't know, I'm yet to kind of like fully understand like, what a world where people aren't driven by these materialistic, potentially egoistic objectives would look like. Mm-hmm. And I feel like we're kind of limited in our sight that we only live one life, and I mean, it's obvious, but what I mean by that is the only way we have only means of measuring our impact is, as we go throughout life, not as we leave life and kind of see what we've left behind. And I feel like, the rat race that you were mentioning, it might feel like psychologically, good in terms of like dopamine or like just kind of like moving or like being on the go.
Clear objectives.
Yeah, clear objectives as opposed to just uncertainty, right? But I feel like that could also be just like, meaningless in the whole grand scope of like the universe.
Yeah. One thing additionally about growing up in a small town, I think if you look at the sociological data for my hometown, the average salary for a family is something like $25,000 a year. So very low, right? And when nobody has money and nobody's ever expecting to get like vast amounts of money, that suddenly kind of changes people's reward function, because it's suddenly about like, well, how can you help people? How can you make sure that if someone's suffering, like you're able to help get them the support that they would need in order to be successful? How do you help grow students such that, they might have a chance of getting to kind of a better life? And those are all, I think if you take kind of the prestige factor out of the equation of like, all right, money is not the thing that I'm after. Credentials are not the thing that I'm after. Given that, what is the best amount of time that I can, what is the thing that I could do that would have the most net positive benefit for humanity at large along the way?
How do we resonate with the ideology of, giving and not expecting? And helping others? And I guess for our last question today, how would you define, I think you already touched upon this a little bit, but I guess if you could define, a happy life in one sentence or maybe two, but don't get straight to that. I mean, or how would you define a happy
life? It's a great question. When I look back on my career, the thing that I derive the most value from is how much I've helped other people be successful and grow and learn. And those things are what give me very great joy in terms of my career and my life. It's being able to know that I meaningfully unblocked something that was, keeping someone from their full potential, or was able to help connect them with the right resources that they needed at the right time, such that they could accomplish something. And in general, if you have momentum, if you're able to successfully complete one project, you see more opportunities along the way. So there's this concept of, if you scale a wall, your responsibility is to send a ladder back down. And I feel that very deeply.
Yeah, I could definitely resonate with that. I think, like, for me, the biggest thing is like helping somebody, but then, a year later or so, kind of just seeing how well they're doing and them kind of like appreciating that, how much they grew like from your help. And I feel like the power to do that is kind of, it's like the greatest feeling. I don't think anything really beats that. And I think, at least for both, I think what I've noticed in helping others, it's not simply the process of like helping itself, but instilling in that individual that they can also help other people as well. Sort of like a pass it on.
That's one of the reasons why I love open source so much, is because I think it's the closest thing you can get to public service in the software industry. You're giving something freely with the expectation that, it's not for money. It's because you enjoy doing it and you hope that you can unblock, some sort of problem for people at large, and that others can learn from the work that you've just done.
Well, thank you so much, Paige, for taking the time today.
Absolutely. This has been a lot of fun.
Really enjoyed the conversation.
Thank you.
Again.